In triangle A, B, and C, the measure of angle B is 90 degrees, BC equals 16, and AC equals 20. Triangle DEF is similar to triangle ABC. Which vertices DEF correspond to vertices ABC respectively, and each side of the triangle DEF is one third of the length of the corresponding side of the triangle ABC. What is the value of sine F? I think Sam.
Yeah, Sam's got this one. This sounds like a.
Just kidding.
Was it
Think
sine, cosine,
for
tangent?
biologists.
I can do it. Trey, you want me to do this one? I just don't have a fancy board like you guys.
Yeah, that's true.
We could
Just
test
talk
your
it out.
skills. You seem to know a lot
could
of
indeed.
knowledge.
All right, I can take that one. So this is a trigonometry question, and it's got some similar triangles in there. So what we're first going to do is I actually copied this onto my screen, and the reason why I did is because it is a lot of text, and it can be a little intimidating at first. We do this in geometry a lot, where we give all this information kind of in written form, and if you don't draw it out, it's kind of hard to manage. So I'm going to draw this out, and I'm going to do triangle ABC right here. And I'm going to point out that it says the measure of angle B is 90 degrees. So right off the bat, we know it is a right triangle. So I want to draw something that looks like a right triangle. So here we got triangle. Nope. Fix it a little bit. So the other thing you want to be careful about, that is not any better. All right, somehow it got worse. Try one more time. One thing we want to be really careful about these is when you are given information, for example, that the measure of angle B is 90 degrees, that's really important in these similar triangle problems and trigonometry problems. So we want to, as we're kind of drawing this, I like to sketch a triangle and then label my important angles. So what I'm going to do is I'm going to call this B because it's 90 degrees. And we want to really make sure we get that, because if we don't, if we call it angle A, something like that, then we're going to end up getting the wrong answer after we do all this work. So it's triangle ABC. That's really the only angle given to you, so we don't really care about the other two. I'm going to call this AC. You could have flipped it around and called it the other way if you wanted to. Then we want to keep going through this information, and we have BC is 16. So I'm going to come over here, and I'm going to find BC is 16. And then, I think I'm always writing really small now. Write that a little bit bigger, 16. And then we have other information that says AC equals 20. So AC, and I'm kind of noting as I do this that AC right here, oh, it was 20, is the hypotenuse. So it's kind of just sticking in my head as I work this out, especially because we know that this is going to have some trigonometry in the end. So triangle DEF is similar. Well, it says triangle DEF is similar to triangle ABC, and vertices DE and F correspond, which means kind of that they're in the same spot, or they kind of align with it, to vertices A, B, and C respectively. And what we mean by respectively is that you notice the order D, E, and F, and the other order is A, B, and C, so we know D and A need to be in the same spot, we know E and B need to be in the same spot, and we know F and C need to be in the same spot. So when you hear respectively, think the orders are important there. All right, so I'm going to draw another triangle. I'm going to take a look at this really quick and notice that it says, and each side of the triangle DEF is 1/3 the length of the corresponding. So the only reason I quickly noted that is I should draw my triangle smaller. Scale is, it's not super important that you get the scale right, but it helps to have at least, one should be bigger, one should be smaller. Otherwise, it can get a little confusing. I'll do this one in green. And this right here is going to be triangle DEF. All right. And again, we noticed that angle B was my right angle here. I'm going to highlight that. And we said angle E corresponds to that. So I do have to be careful and make sure that I call this angle E. And where I have angle D here, or sorry, where I have angle A, I'm going to also have angle D. So I'm going to put a D up here, and then we're just left with F. All right. Now we know each side of the triangle is 1/3 the length of the corresponding triangle. So we could figure this out by saying the length of EF has to equal 1/3 of BC, right? These are corresponding, so BC and EF are in the same spot. So here's what we're going to say with that. EF is equal to 1/3 of 16, right? Because that's the length of BC. So I'm left with 16 thirds. This is kind of a rough problem. So
Really
I'm hoping
is.
that you're okay with the trigonometry parts of it, and that maybe you're struggling a little bit with the fractions, and maybe the fact that we're adding a couple of concepts together. But this isn't going to work out necessarily nicely, but it'll work out. So we also know that 20 right here, this corresponds with DF, and so we're going to say DF equals 1/3 of 20.
Yeah, these are not nice numbers at all. They could have been
No.
a little bit nicer.
I know, your teacher is kind of mean, but it works, and so actually we're going to have some fraction dividing in here.
Oh, lovely.
We
I
are
love that stuff.
also actually going to have some Pythagorean theorem
Fractions.
with it, so that's great. You know, there actually, now that I look at it, there is a shortcut to this. Like I can quickly identify, so let me get to that in a second. So we are looking for the value of sine f. Right, so here's f. If you remember, everybody always seems to remember this. SOHCAHTOA.
SOHCAHTOA.
I'm not going to go through all of these, but this is kind of just a quick way to remember the relationship. So with the SO here, we have the S for sine. And then we have the sine of whatever angle it is. I'll put a little theta here, equals opposite over the hypotenuse. So here's what we're looking for. We're going to try to say we are looking for the sine of f. That's going to equal the opposite side over the hypotenuse. And this is something that a lot of students get mixed up. When we say opposite, we're referring to opposite of angle f, right? So we're actually talking about the side directly across from it. So in this case, we're saying sine of f equals the length of DE over my hypotenuse, which is right here, over 20/3. 20 over 3. So again, you're kind of seeing that we're going to be doing some division of fractions here. Okay, now in order to do this, though, we need to first figure out what is the length of DE. And so you should be thinking, you should be kind of sad about the fact that you have to do Pythagorean theorem with these fractions, to be honest.
You should be sad.
I would be. I have a shortcut in my head that would work out pretty well because I notice the numbers 16 and 20 and think about my Pythagorean triples.
Right.
So your teacher might tell you about Pythagorean triples. You should memorize them. It will save you a lot of time.
Yeah.
Because if you're already comfortable,
Good example.
yeah, if you're already comfortable with Pythagorean theorem, you don't have to keep doing it when these numbers come out like this. So I'm going to tell you, based on what I know, that this should be, actually maybe this won't work. Let's see if it does. 9 over 3. And the reason is because I know that this should be 9. This is a 3, 4, 5. A 3, 4, 5 triangle that's kind of scaled up a little bit. But let's see if that actually works because it's got a fraction in it. So what we're going to do, if you don't know the triples, we're going to do 16 over 3 squared plus, and if I didn't know this side that I just told you is probably 9/3, which would just be 3. So actually that's not going to work. All right, so we're going to have to do this anyways. Right, because 9 over 3 is just 3. Yeah. So, where was I? Okay, so we're going to do plus b squared equals 20 over 3 squared. And then I'm going to do 16 squared over, so this is 256 over 9 plus b squared equals 400 over 9. And I'm just kind of working through this to solve for b. So here's what I have now. I got to subtract from both sides. So minus 256 over 9, minus 256 over 9. B squared equals 144 over 9. And then we do the square root of each side.
At least they're perfect squares.
They are, yeah. So I got b equals 12 over 3. Oh, that would have worked. I just did it wrong in my head for some reason. So this is 12 over 3. If you kind of want to know how that works, and this is not 9 over here, this is also 12. If you do know the Pythagorean triples, it could like take too much more time. One of the triangles is a 3, 4, 5 triangle. So if you notice any multiple of these numbers, as long as you use the same multiple, is going to give you that. So what I was thinking in my head was, oh, I did that backwards, didn't I? Should be like this. 3, 4, 5. What we're actually doing is multiplying it all by 4, so we're scaling it up by a factor of 4.
Scaling it up, yeah.
So if you were comfortable with that, you could have just quickly said it's 12 over 3, 16 over 3, 20 over 3. So anyway, we're doing sine of f still with all these fractions equals 12 over, nope, that's a 13. Opposite, 12 over 3 divided by 20 over 3. And a couple ways to divide this, but the way you probably know is to multiply this by the reciprocal. These cancel out, and I get 12 over 20, which simplifies to 3 over 5. All right. So again, I could have cut out a large portion of this right here if I knew Pythagorean triples.
You could also do the Pythagorean with the 20 and the 16 and then do a third rather than having to do it with the fractions.
Yeah, so that's another good way to do it. There's always a couple. But if you don't like fractions, and honestly, I hate when people say they hate fractions, but I avoid them when I can because it's just a lot of room to make a mistake.
It's more,
right?
yeah, it is. It's more work.
So you always want to try to simplify it in a way that you can avoid fractions if you can.
I don't think we'll have trouble convincing students to do that.
No, it's just you also have to know how to simplify them, and that's
That's
True.